So hello and my name is Matti Autioniemi and I'm the CEO and one of the co-founders of Aurora Powertrains. And Aurora Powertrains is a company founded in 2017 in Arctic Circle, Rovaniemi, and we are a spin-off from local Lapland University of Applied Sciences. And there's some history in the university as well. So we started the electric snowmobile development project back in 2010 in the university. And we had a total of 4 R&D projects related to electric snowmobiles in the university. And after the last one, which ended in 2017, we decided with the core team of those projects to spin off Aurora Powertrains. And that's where we are now at the moment. And we've been there for more than 5 years now. And the Aurora Powertrains is the company that develops and manufactures e-sled electric snowmobile. And then we also have kind of a brand or auxiliary business called Aurora eMotion, which provides the first electric snowmobile safaris in the world. And it's basically, we planned to start to manufacture the electric snowmobiles right in the beginning of the company in 2017. But soon we realized that maybe this is not ready for the mass markets yet. So we kind of changed the business plan a bit in the start. So we decided to have this safari company, which is basically a product development platform for us. So we can keep the electric snowmobiles in our own hands and see how they behave in the real use, and update them when needed and fix all the bugs you will find in the software, and also see how the electric powertrain and the selected components work. And they all of them didn't work at the start, so we needed to find alternative manufacturers for several components. And now we are happy with the powertrain, and we are going to launch our next model for sale. Yeah, a little bit more about the Aurora eMotion. Yeah, so as said, it provides electric snowmobile safaris. And in 2020, we made collaboration agreement with a big Finnish destination management company called Safatica. And now we have 3 destinations in Finland in this collaboration, where we operate about 15 to 20 e-sled. As you can see in the picture, so all of those are electric. So they are in Lehtojärvi, which is nearby Rovaniemi. And then we have locations also in Ylläs and Levi under this collaboration with Safatica. And then we have a couple pilot partners. So one of them is located in Svalbard in Longyearbyen, and it's called Hurtigruten Svalbard. They have a fleet of 8 e-sled there, and they also run guided tours. And now it is already the 4th year they have the electric snowmobiles there. And we also have a pilot partner in Pyhä called Experience Pyhä, and they have a fleet of 7 e-sled there, and they are also running them for the 4th year. So, and we have accumulated last winter it was over 100,000 kilometers with the fleet, and more comes this year. And about the e-sled, so the first version is a conversion, as you can see. So on the left, you can see basically the powertrain. You can see it in real when we go there to the workshop and open the hoods. So that's what you will see there. So what we have there is the motor controller here on the front. This is the motor controller. Then we have the battery pack. Then we have the electric motor, and then we have the onboard charger and the charging inlet. So that's basically what you need to create an electric snowmobile. Of course, it's a little bit more complicated than that, but those are the kind of the basic building blocks. And in the middle picture, you can see how we have placed them there. So it's kind of a bolt-on kit to convert existing combustion engine snowmobile to electric. So we didn't modify the chassis, we just removed the combustion engine components and replaced it with our powertrain. And well, outside you cannot tell which one is it. So it looks the same as a combustion engine one. Only difference is that instead of the fuel tank, you have the charging inlet there. So that's what we have been doing so far. And this is the new model we have come up, and which we have developed for a couple of years now. And now we are ready to, or actually have launched it. And this has been designed ground up as an electric snowmobile. So we were able to find kind of new ways to make snowmobile, and could make a couple things in a different way and in a new way. So for example, I think many of you have seen snowmobiles before and maybe even driven. So you can see that the chassis, it's much more narrow. So we don't have the huge side panels here. So we have made it much more compact. The ski width is still the same, even though it looks wider, but it's still similar ski width. And in the front, we have developed our own front suspension structure, which we have a patent for. So it's something that you cannot make on a combustion engine snowmobile, because the combustion engine technology takes a huge amount of space there in the front. So you have first of all the combustion engine, then you have all the exhaust pipes and mufflers and air intakes and whatever. So they need a huge volume of space there in the front. And when you have electric, you don't need all that space for the components. So you can think things in a new way. And the advantage of that suspension is basically, first of all, longer travel, so we can take bigger bumps, and also the ski width remains the same despite how the suspension works. So it doesn't do this kind of a horizontal movement, which typical snowmobile suspension does. And it basically enhances the efficiency of the snowmobile, so we can get basically longer with the same amount of energy. And there's been also many other developments. So we have a total of 6 patents filed, and 3 of them are already granted. And we will continue those of course, to different markets. So on those 6 patent applications, we will get multiple patents in different markets. And yeah, it also has a competitive price. So we kind of kept the cost in mind as we have developed the new one, because the typical customer wants to get it as cheap as possible. So we have tried to keep the price in the range of the typical snowmobiles. So for this model, we estimate the sales price of 15,000 to 23,000 euros, depending on the battery capacity. And yeah, so it's been launched for pre-orders in the end of last year, and those pre-orders will be delivered for the next winter season. And yeah, here's a couple more pictures of the new one. So here you can see how the front suspension runs all the way to the base of the steering column, basically, so we can use very long shocks there. And yeah, the front is shorter, so the driver can see better to the front of the snowmobile. And then we have a single piece composite structure running here all the way. So this is one piece structure, and we've been able to eliminate typical kind of A-frame structures which create this kind of a pyramid shape here. So we've been able to decrease the bill of materials quite significantly with that one part. What else? It has a digital display 7-inch, and the charging inlet is there. It can have the Type 2 or CCS, and the motor will be located here in the bottom on the kind of it is directly fixed to the upper sprocket. We will have a belt drive here and gear ratio or the reduction gear, and basically all the power electronics are located here in the middle. So in case of a collision, there's no kind of parts which will be damaged here in the front, no expensive parts. And the battery is located here on top of the tunnel, which is basically the safest place on a snowmobile. So in case of a collision, the battery doesn't get hurt.
It's only the driver.
It's always the driver, unfortunately. Yeah. Yep, and then more about the battery modules. So it's actually one of the core things that we do. So the E-sled is kind of one nice product and also proof of a concept for our own battery modules. And they have a scalable structure, as you can see. So this is an example of an E-sled battery with the maximum of 6 modules. So there you can see one battery module here, and then 1, 2, 3, 4, 5, 6 in total. And one module is 3.5 kilowatt hours, and in this pack we have about 21 kilowatt hours of energy. And we can configure it to different voltage levels. So one module is 120 volts, and by connecting them with these orange bus bars, you can create different kind of battery packs easily. You can connect them either in a kind of a queue like this, or you could have another pack here, and you could make the connection this way also, to make a parallel and series connection as you like. And it has integrated heater, which is mounted in the bottom of the module. Each module has its own heater, and each module can control the heater as needed. And then we have it's liquid cooled, so you can see these gray things here. So these are cooling plates which are placed in between the modules, and the coolant runs in from this tube and comes out from this tube. So they are connected in parallel. So the coolant runs like this through each plate. And it's a very, very compact package. And it's kind of because it's the first application was the snowmobile, so we had to squeeze the size to minimum and to maximize the energy density and to actually fit it into the snowmobile. And the other application could include off-road, power sport, recreational vehicles, or electric boats, work machines, or even energy storages. So we can kind of scale this to different needs. And related to this, we have also in-house developed BMS.
What type of cells?
Lithium-ion NMC. And they are these pouch type of cells. So they have this rectangular shape. So that way we can kind of maximize the space in the snowmobile, because typically, as you can see on top of the tunnel, it is kind of a rectangular shape also.
And how far down, if you leave it outside, so it cools down, how cold can it get before you can charge your
It's a typical for the NMC. So if it's below 0, you cannot charge it. So that's why we have the heater, so we are able to heat them, and then.
But how far down can you run them? I mean, if it's cold down to -20, -30, then you must use the energy in the battery to heat it if it's up in the mountain.
Yes.
Can you unload energy from the battery down to my...
Yeah, when it's cold. Yes, yes. So you can use that also. Discharging is possible when cold. Of course, you get the...
How cold?
Well, we have used them in -40.
Okay.
Yeah, but of course you don't get the same performance. You get just a little bit of power, and the battery cannot release the full capacity or the full amount of energy. Yeah, 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 yeah. It can. And yeah, here's a couple more views of the battery modules, and they have about 190 watt-hours per kilogram of energy density on the pack level, so including all the components you see. And each of the modules is waterproof as is, so we don't need necessarily any kind of enclosure for it. So it is waterproof and can withstand the environment. And we have decided to go with the external cooling to reduce or minimize the risk of coolant leaks. So if one of these plates would, for some reason, leak, the leak would be outside the modules, not inside the modules. And yeah, those things I said already. So there's the proprietary bus bars and the BMS. And yes, on the E-sled, the minimum is 2 modules, which means you have 7 kilowatt hours of energy, and which is good for 40 kilometers, or the maximum of 6 modules when you have 21 kilowatt hours and a range of 100 kilometers. And of course it affects the weight of E-sled. So with the 2 modules it will weigh a bit less than 200 kilos, and with the 6 modules it will weigh 270 kilos. And other tech we have developed, so we have our own vehicle charge control unit. So it's kind of a compact unit to facilitate the control of EV charging. So it basically communicates between the EV and EVSE, the electric vehicle supply equipment or the charging station. And it's currently compatible with the most common standards, and it has the PWM and PLC and LIN-CP interfaces. And thanks to those it is also future proven. And on the vehicle side it communicates through the CAN bus. And it's suitable for vehicle-to-grid applications. And although it seems big here, so it's the size of basically a credit card, and kind of this thick. So it's a very small compact unit. Yeah, and regarding V2G, so we are participating in this Energy ECS EU project, and it is a large 3-year consortium project on the smart energy and smart and secure energy solutions for future mobility. And the project aims to develop a set of technologies to improve the digitalization of e-mobility systems and related energy solutions. And the total budget is 33 million euros. And there you can see the link to the project as well, energyecs.eu. And it has a total of 30 partners from 8 EU countries. I think some of these companies are present here, or there's, for example, from Sweden, RISE is participating in this project as well. And yeah, as you can see, there's many big names as well, so it's a big project. And in this project there's 6 different use cases. So there's use case 1 is for kind of drones, and they are creating this kind of autonomous drone ecosystem on mobile platforms. So they are researching how to kind of, for example, land the drone on top of a bus roof and charge it there, as an example. And then we have the use case 2, which is smart containers in intermodal transport. And then we have use case 3, which comes closer to today's topics. So it's about smart grid with e-mobility. And our use case is kind of collaborating with this use case 3. And our use case is, we are the owner of use case 4, which is vehicle to grid. I will tell a couple of words about it on the next slide. And then use case 5 is self-powered system in tires. So Nokian Tires is developing their own kind of system to take the energy to sensors from the spinning wheel, basically, of the spinning tire. And use case 6 is about autonomous driving of EV to charging station. So they are kind of on the bus depots. They would like to drive the bus to the parking lots and also plug into charger automatically, because the bus depot is actually the place where the most accidents happen. So they want to make that automatic. Yep, and yeah, regarding that use case 4, we will have our pilot at this Sunday morning resort in Pyhä, where are these electric snowmobile safaris operated. And there will be a demonstration of vehicle to grid and microgrid applications. The site has solar panels and small energy storage installed already. And the site owner will also invest into V2G compatible electric vehicles. And yeah, they already have the snowmobile fleet. And our job is to equip the snowmobiles with the new vehicle charge control unit, and also with the components we get from the project partners, for example, bidirectional chargers and on board wall boxes. And we will create the system together with the partners, so we can actually demonstrate different kind of V2G applications there on site and actually in real use. So they will run their safaris as they would, but they have all the V2G applications there in parallel. And there's many kind of interesting use cases when it comes to electric snowmobiles. For example, now that the snowmobile is electric, and you typically store your typical snowmobile in your garage during the summer. But with the electric snowmobile, you could actually do something with it during the summer as well. If you can plug it to the charger, and perhaps you would offer some kind of V2G services during the summer. And then what is more interesting, if you own a fleet of snowmobiles, maybe 10, maybe 100, maybe 500. So that creates quite a large virtual power plant already. And that is something really interesting. And that's something we are working on this project as well.
And in the winter time you will have the boats
Yeah.
going way to home or whatever.
Yeah, true. And yeah, there's some pictures from the safaris, and that's why the people from all over the world come to here to the northern parts of Scandinavia to see the northern lights, for example. Yeah, so thank you.